Velociraptors, and welcome to my classroom. In today's video, we're going to be discussing or investigating percent composition. And in order to do that, I have two samples in front of me here. Both of them are supplements that you'd pick up at your local grocery store if you are calcium deficient or increasing your calcium intake. On the left here, I have a gummy chewable, and on the right, I have some regular old swallowable pills that you might take. Now, by both of these compositions, they're proposing that they're composed of 10 grams of calcium. Now, when you go to the store and you buy them, you're probably thinking it's just calcium mixed with some stuff. But actually, they both have compounds that are contributing the calcium, and they're different. In the pill, the calcium is contributed through calcium carbonate, while in the chewable gummy, the calcium is provided through calcium phosphate. And the question that we're going to investigate today is which one of them actually provides more calcium. Let's look at the examples. The question that we're really asking is how much of the actual 10 grams is calcium? Now, in order to do that, let's get rid of the samples and let's actually look at the molecules. So here I have calcium phosphate and here I have calcium carbonate. Now, very quickly, visually, you can notice that calcium phosphate is much smaller. Calcium carbonate is much smaller than calcium phosphate. Now, normally what happens here is a student misconception happens. And a student will say, well, calcium phosphate has 3 calcium atoms for every 15, because there's 15 total atoms. And they'll say, well, 1 calcium atom is for 5 atoms in calcium carbonate. Now, we've been taught in mathematics to compare two fractions. We can cross multiply to determine which one is bigger. So 5 times 3, well, that's 15. And 15 times 1, that's 15. So if we do it based on this knowledge, this assumes, this is stating that they're in equal quantities of calcium. Now, this is wrong. Wrong. Students do it all the time, though. I need to remind myself that this has a huge assumption associated with it. And when we take assumptions, I've already made an assumption, like for example, the samples that I've given you, we're assuming that is all, that it's the exact amount of calcium that's provided in it, that it's measured off the quantity, that it's based on the mass associated with each pill. Just like here, you made a big assumption that each of the atoms is the same mass. Now, very quickly, we can see based on size, they're definitely not the same size, and they are not the same mass if we look at the periodic table. So we cannot evenly divide the molecule up into atoms because that's not what we're asking. We're asking based on mass, which means we have to take into account the mass. So we don't want to do ratios of atoms. We want to ask more specifically then, if we had 1 mole of each of these substances, what percent of that mass would actually be calcium? And in order for us to do that, we need to calculate some molar masses. So let's remove that question and pull up our primary question. We need to calculate the molar mass of each of the individual molecules. So in this case, let's get these a little over so I have a little more space so that they line up better. The molar mass of calcium phosphate is 310.174. And if you forget how to calculate molar mass, check out that first video. If I calculate the molar mass of calcium carbonate, it's 100.86. Now that's great and all, but I need to know what percent. And in order to figure out the percent, I need to know, well, how much of that mass is actually contributed to calcium? Well, in order to figure that out, I need to look at, so let's get rid of this so that we have some more space here. Okay, I've got molar masses. I need to know what mass of that 310 or 100 in this case is actually calcium. And in order to do that, I look at the atoms. So there's 3 calcium atoms. Calcium has a molar mass of roughly about 40.078, and I need to multiply that by 3. So that means that the total mass associated with carbon, or calcium in this case, is 120.234. Now, for the other molecule, there's only 1 calcium, so it's 40.078. That's telling me the mass that is calcium. In order to actually calculate the percent, I need to figure out what this is in relation to this total. So total mass, partially calcium. So let's take a look at that. That would mean that I need to take, for example, the one here on the left, calcium phosphate. I would need to do 120 divided by 310, the molar mass, times 100. That's going to give me the percent calcium. So the percent calcium for calcium phosphate is 38.76%. If I do the same thing for calcium carbonate as the contributor, calcium carbonate is 40.078 divided by 100.086 times 100, which means that it's 40%. So the percentage change here is much higher here. Now, remember, we showed the ratio of the atoms. According to the atom ratios, they are in equal quantities. But we can see here that actually calcium carbonate by mass has more calcium in it, just like calcium phosphate has less percent mass in it. That's what we're talking about percent composition. Let's do an example that's not one of these two. Let's take a look at that hydrate molecule that we looked at in the first video, copper sulfate pentahydrate. Now, we should already know how to calculate the molar mass of this compound. And we want to ask a question, by what percent by mass is it copper? So out of this whole molecular mass, what percent is actually copper? In order to do that, we need to first figure out what the molar mass is, which we did in the previous video. It's 249.677. Now, in order to figure out the percent mass of copper, I need to take the mass that's copper. Well, there's one copper, so that's 63.546, divided by the total molar mass of the molecule, times 100, and it's roughly 25.451%, which that is how much percent by mass that it is copper. That's how we do percent mass. Now, of course, in the original samples we looked at, right, we had the pill and the gummy. Now, of course, you're not going to take that entire dish of gummies or that entire dish of pills. We might actually take just one pill. Well, just to help illustrate our point, if I take 2 pills, which is the recommended dosage, that's 1.2 grams of calcium. If I take 2 gummies, which is also the recommended dosage, that's 1 gram. Based on our percent by mass, though, if I take 1.2 grams of this and I take 1 gram of this, how much calcium do I actually get? Well, you should be able to figure it out now. And if I do my math, that's just going to be multiplying the percent by the actual mass. That means that this is only going to give me 0.39 grams of calcium, where this is going to give me 0.48 grams of calcium. Great work, Velociraptors. Now you understand that we need to use percent composition in order to determine how much of something another is contributing. For example, what we worked out is in this case, even though this has 1 calcium atom in this sample and this has 3, by mass, this is going to provide more calcium. So if I have equal masses of both, this one will definitely prevail in the number or the amount of calcium that it's contributing. That's what percent composition is, and that's how we can use it. Thanks for tuning in.